Hi, how's it going? My name is Beatriz Rodriguez, and this is my attempted revision of Alfred Wegener's theory of continents and oceans and continental drift. Revision. Just trying to revise his work, so let's have at it. The following presentation are the results of my research involving the Pangaea theory. This is, in essence, a physical attempt to revise Alfred Wegener's work via visible scientific proof. The work I am attempting to update specifically is Alfred Wegener's 1912 theory of continental drift, as well as his thoroughly elaborated descriptions of it in The Origins of Continents and Oceans, published in 1915. This publication and scope of research is possible via a group of unlikely avian participants, the Lory parrot family, and the African grey parrot family, as well as Permian period Glossopteris, Dicynodont theraspids, and Stereospongyle trigosaurids, as well as a few diamond mines and coal mines. I'll even use a swamp in this presentation. I also plan to briefly use a great little online page called paleobiodb.org, which is an online Canadian project involving collecting and making geographically visible all of the dinosaur bones that have been found on this planet. Excuse me just one second. This paleontology navigator has proven extremely useful in studying this fascinating phenomena. To be honest, most of my research has literally come from epiphanies in observing the planet via Google Earth, an app extension I have only owned for 3 weeks. The story of how this discovery took place is an interesting one. I was looking to buy an African grey parrot, oddly enough, being that they're the smartest parrot on Earth, according to pet bird aficionados and experts, noting here, of course, the famous study of the African grey parrot Alex by animal psychologist Irene Pepperberg, who was able to prove that Alex had the intellectual capacity of a 5-year-old child, an extraordinary achievement for any animal on this planet, more extraordinary being, of course, that Alex was not of the human race. I kept studying the African grey as a potential new family member, but I just didn't have the heart to pay over $1,000 for a pet I couldn't pet. It didn't make sense. After all, if I just wanted to have a repetitive conversation with someone, I could call my mother. I was disheartened. I searched elsewhere and found buried deep in avian breeder Bibles another bird. As it turns out, I found an enormous group called the Lory, playful, interactive, attention-demanding, small, microscopic puppy swirls, and extremely intelligent. I began to save money to purchase a Lory. I still am. Since I could not buy the bird, I hung out with bird owners on YouTube, watching Lories play and enjoying not having to clean out a cage yet. As I sat there and watched these birds, I started noticing behavioral traits in some of the birds of the Lory genus. I realized that the chattering Lory had many of the behavioral traits of an African grey, and even some of the intellectual capabilities. I thought I was going out of my mind. There was nothing similar between the African grey and the chattering Lory, or the red Lory, right? Could they be siblings? I set out to prove myself wrong. While in that pursuit, I stumbled across a big discovery, which I will outline here. So, we begin at the beginning. This is an excerpt from Wikipedia. In 1912, a book was released called The Origins of Continents and Oceans by the now world-renowned meteorologist Alfred Wegener. In this piece of literature, Wegener stated that the continents had once been a single landmass called Pangaea or Gondwana. Wegener based his theory on the locations of coal mines and the similarities of the edges of some of the landmasses as well as their compositions. He also added to support his theory the locations of where Mesosaurus and Glossopteris had been found around the planet, along with several Permian period species of ancient Earth. Remember, this is 1915. Alfred Wegener was a man ahead of his time, as well as limited by the technology he had available. He even he furthered his research by using measurements of ocean waves and whatnot. Believe it or not, as hokey as it seems, he was actually delving into erosion properties. So it's not as he did a really great job in his presentation. But today, we as a society have at our disposal a much more vast cache of technology and information readily available to us. My theory is that Pangaea did exist, but not in the model presented by Alfred Wegener. supported by a wider variety of dinosaurs that existed with the Permian Carboniferous periods, which may lead to the conclusion that our planet may be far older than previously stated for models that currently exist within our education system. Think of this as a threat of an update on Pangaea. The original purpose of my research was intended to be simply a sibling relationship between lories, lorikeets, and African greys, as well as Timneh African greys, and to prove that they were once one and the same, living in the same area at one point in time in Earth's history as a single genus, as a single group, within the same location. One of the aspects of the lories I found interesting, besides their fantastically bright colorization, was their unique diet. Unlike their soon-to-be-proven relative, the African grey, lories live off of fruit, flowers, nectar, and the similar. A very, very high carbohydrate diet, very rarely eating seeds, due to the simple fact that their gizzards cannot handle the digestion. In fact, if a lory is supplied only seeds in their diet, it will shorten their lifespan. Their bodies are adapted to their diet in the most efficient way for the species to survive. A subject I will elaborate on further on. Very, very short elaboration. African greys live off of seeds, nuts, vegetables, and fruit. A higher copper diet resulting in a much broader, more available dietary requirement. Just Central Africa, climate changes a lot. Something I'd like to note here right now is one of the things as a human species that we have in regards to our liver is that whenever we consume a heavy metal, anything that's a heavy metal, we produce a lot of glutathione. And catalyst. Catalyst is also a heavy metal chelator. Despite the fact that the African greys are gray and it is probably a melanin, it's interesting to note that this particular chemistry that comes from the liver, especially when it comes to breaking up something like a seed which contains a high amount of copper, it could be possible at some point in time it changed the melanin, and it even has the potential to chelate it if they consume too much of it. The size of the lories played a large factor in my studying them, as I tried to figure out how much of their brains is actually used in intellectual survival and how much is utilized in biological function. How can an animal that is so small possess such an intellect? Is their intelligence directly a result of the size of the brain and the relative size of their bodies? Is there a human theory that big brains are better incorrect in that assumption? The intellectual capabilities of a lory is typically utilized for survival, from finding food to being able to ward off predators to evading them altogether. And no predator's going to mess with a flock of birds that's talking like a bunch of humans if they've been hanging out with people long enough. They can even imitate the predators in the same way. It is also interesting to note that these birds, neither the African grey nor the lories, migrate. Both birds are nearly completely depend on their intelligence to survive statically, remaining in a specific region. Excuse me. All right, so let's go ahead and meet these lovely birds, shall we? This is the chattering lory here. He's from Maluku, Indonesia. He goes to 30 centimeters adult. So let's go ahead and bring him up. Hello, chattering lory. How's it going? Then we have the Congo African grey. He's from equatorial Africa. He goes to 33 centimeters when he becomes an adult. So our lovely Congo here. This is the Congo. Hello, Congo. Moving along. This is the black lory here of West Papua. He's 32 centimeters as an adult. And this is the Timneh African grey from West Africa, from 28 to 33 centimeters as an adult. Going down here, if you notice, there's a lot of similarities between the Timneh and the black lory. This is the black lory here. This bad boy is from hang on. Oh, I didn't add that. Oh, there he is. Right, he's also from East New Guinea, and generally New Guinea and overall. And yeah, right, black lory bird, Peninsula Pohnpei. The Pohnpei lory is a pretty interesting one. The Pohnpei lory here, if I can, it's kind of a smaller bird. He's actually one of the state birds of Indonesia, Micronesia, excuse me. He grows at a whopping 24 centimeters as an adult. Not typically used as a pet, believe it or not. And we have the red lory. Red lories from New Guinea in Australia Pacific. They mature at 31 centimeters as an adult. And of course we have the Timneh African Grey, which possesses many of the similar traits to the Congo African Grey. They're a little bit smaller and darker colorization. One of the most notable aspects, of course, is that they sport a lovely maroon tail, which is similar to the Pangaearevisional. This gorgeous little bird here grows to from 28 to 33 centimeters at full maturity as an adult. Those guys are from West Africa, so say hello to the Timneh African Grey. Really cute. Now, this is, make sure I've got everything on here. Oh yeah, of course, and we have the also popular rainbow lorikeet, which is native to Australia, and they are just all over Australia. Lorikeets are actually, you can find videos on lorikeets all over YouTube, and you know they fly in flocks and they eat in flocks. Very energetic little guys. Sometimes if you end up feeding lorikeets off of your porch in Australia, they'll end up wrestling. Extremely energetic, extremely interactive, and even friendly as a wild animal, which is really interesting to note. The following is a quote from Wikipedia, and this is in regards, of course, to our friend here, the Timneh. Growing from 28 to 33 centimeters in length and weighing 275 to 375 grams, the Timneh is a medium-sized parrot. Its plumage is mainly a mottled gray with a white face mask and pale yellow eyes. Compared with the only other recognized pistachious species, often known as the African grey parrot or Congo African grey parrot, the Timneh is smaller and darker with a dull, dark maroon rather than crimson tail and horn-colored patch on the upper mandible. You can see that here. As in the nominate species, the Timneh parrot is also a very intelligent bird and a skilled mimic. The Timneh parrot may be less nervous and more going around human beings and can learn to talk at a younger age than the Congo African grey. I find them to be skittish. I'll go ahead and elaborate on that further. Now, one of the reasons I actually have drawn your focus to the Timneh and not the Congo, which is the more popular African grey because they are of higher intelligence, is due to this. If you notice the colorization here, if you take a look at the gorgeous colors going on, he's got like nice dark gray going on, and his beak is turning black. He shares many of the traits of the black lory right here. This is a young black lory. Their eye color changes as they grow older, and oddly enough, they look nearly identical to a young Timneh African grey, which I found extremely fascinating. One of the other aspects, you can see that coming in there, this is a reddened tail. Unfortunately, he's got more colors going on. When they're young, they have like yellow and red coming in on their tail. But as they get older, actually more of their feathers do change color, and he does turn into a nice brownish maroon color, emulating the tail color of the Timneh. Now, one of the aspects I'd like to point out here is this feather scalloping. You see this nice scalloping and the color going on, and how this guy has something similar going on here. Actually, a lot of the lories have that same trait. Let's see if I can find you a better one. Yeah, this is a cardinal lory. I didn't add him to the mix. I ended up doing some research to determine whether or not the cardinal lory was actually a result from breeding an African grey with a red lory, and no such information exists. So this guy is a work of nature. And you can see here he's got some really great feather scalloping, and it's gray, along with some of the facial mask features, like the little monkey face of the African grey, which is kind of neat to know. The next bird I'm going to point out here is the black cap lory. This is one of the more intelligent birds of the lory family. He's comes in at 31 centimeters as an adult, very interactive, very attention demanding, a very, very strict diet. Not as much of the feather scalloping going on, but part of the same family, also chattering lory. You see he's got some slight feather scalloping there. It's barely visible in the image. Moving along to the dusky lory. Dusky lories from New Guinea. And dusky lory, they're some of the lesser intelligent of the lory family. Very hard to get them to talk, but they're extremely playful. And he's got all this gray area coming in on the back, on his back, and he's got gray scalloping coming in on the fronts, as well as this fantastic colorization that he has. Let me go ahead and give you a quick note here for the chattering lory. Chattering lory is from Maluku, Indonesia, and they grow up mature at 30 centimeters as an adult. And yeah, not as much feather scalloping shown there, but a lot of them do. As they grow older, it becomes kind of more prominent in their old age. And moving along, and this is just a little guy I decided to add in there. This is the yellow-bibbed lory. Say hello to the yellow-bibbed. He's a little bit more demure, much like the chattering lory. They're kind of reserved, but he's also very playful and one of the more intelligent of the lory family as well. Not as popular and a little bit more expensive due to his colorization, and he grows in at 28 centimeters as an adult. Isn't he beautiful? All right. And here's the Pangaearevisional lory that I was mentioning to you before. He's, of course, he's 28 centimeters, a state bird of one of the areas in Micronesia, and definitely clearly visible feather scalloping going on there. Some of the squaring of the tail, but not as many feathers. I guess it's due to his size. I don't know. This is the red lory. He grows in at 31 centimeters as an adult, and he's got some of the maroon coming in here, and a lot of the feather scalloping here on the belly. You can barely see it, but yeah, it's completely there. Typically, you know, whenever I've seen videos of this guy, he looks very small, but apparently he comes in at 31 centimeters as an adult, so it might be just the diet the owners are giving him. He's pretty big, almost similar in size to the African gray. The only difference between the African gray and the red lory is the fact that this guy has a pointed tail. And typically, I think pointed tails is for a long-term flight migration, but it's not happening that way. And moving along, this is the Timneh African gray. This is a seller here in New York. She promotes the birds as a Congo African gray, but once you have the darker colorization, it's clearly a Timneh. It's interesting to note that they have the pied recessive gene, which I'll elaborate on later on. And here's a Congo African gray with a pied going on. One of the more horrific aspects is for capturing these birds. What these people do in Africa is they'll catch a bird and they'll break its leg and they'll tie it to a tree and they lay down a net in the mud and put food on it, and even though the bird is captured in the tree and he's screaming and yelling and whatnot, the other birds take it as a sign that the area is good to visit and is safe because there's a bird there, even though they're not hearing what he's telling them. And the poachers end up catching the birds and they get all scratched up and it's mud, and there's no lack of parasites in Africa. So these birds are bleeding and they're sick, and they buy them up in large quantities. They end up transporting them via something called Africa Air. But I'll get into it further. There's actually a good ending to the story about the African greys there. And here is our ever-friendly rainbow lorikeet from Australia, which goes 25 to 30 centimeters as an adult. Isn't he beautiful? There are also talkers. Some of these guys can emulate digital sounds to where it's difficult, if not impossible, to determine whether or not the sound is digital or actually from an organic source. So let's go ahead and go back to our Timneh here and the black lory. And I remember I was telling you about the similarities between the two, the little face mask. It looks like an undeveloped face mask coming here from the black lory. And yeah, it's scalloping going on a little bit on the lory here. Much more visible on Grandpa over there. Something I find rather humorous about the Timneh is the lory that I'm utilizing to show off the physical features between the lories and the greys, which is the black lory. What's funny is that it's very difficult, if not nearly impossible, to train a black lory to talk. Weird, right? My personal experience with Timneh African greys showed me that they were skittish and temperamental birds, in no way fitting the descriptions provided by Wikipedia. It gets weirder. Despite their similarities, the African grey and chattering lory, which is the lory closest in behavior and intellect to the African grey, have that completely different diet that I mentioned before, acclimatized to the regions in which they evolved. So, but the grouping here is pretty interesting, right? That should be catching your eye right about now. Their dietary habits are clearly expressed in their behavioral and intellectual expression output, as well as their energy levels. In fact, even their temper. Most lories are extremely well-tempered and adjust well to pretty much any environment that they're thrown into, as long as they eat what they need to and are given a lot of attention. They are very demanding for attention, while African greys tend to be more on the grouchy side. Now, why in the heck would I bring up these so seemingly different birds? They're only a parent similarity being that they're parrots. Well, here it is. These are what are now called red factor African greys. Below that is a picture of a black lory. These two pictures of the black lories here are significant because one is very young and the one is very older, your grandpa. You see, much like African greys, as lorries age, their eye color changes, as well as their eye color changes as well, period. And this is the story of the world's
Pairing up
first
two
red African grey.
double-factor pied mutations like these led to this, the world's very first red African grey. It was bred by Henny
Notice the eye color.
Diedrichs in 2007,
See that?
only 9 years
Black lorry.
after the controlled mutation breeding program was started by Vonk van Antwerpen. Vonk originally thought it would...
The following is a quote from an April 2009 publication by an avian magazine called Avizandrum about the red factor African greys, Congo red factor African greys. In breeding the pied, partial red African grey, Vonk van Antwerpen has shown us that the red color presents in the same way as the dominant pied mutation in budgerigars and lovebirds, budgies. He predicted that the total red African grey would be bred when he sold his collection of pied red African greys to Henny Diedrichs and Mike D'Souza. True to his prediction, this has now happened, and even sooner than Vonk expected. He had told Henny that it would take at least 2 more generations to achieve the goal, so you can imagine Henny's delight when the red baby started to hatch. So in essence, these breeders are tapping into a recessive gene of red feathers to breed this fully red African grey. This leads to the conclusion that the African greys were more than likely at one point in time all red, exactly like the chattering lorry. I read some of Henny Diedrichs' publications about the production of the red African greys, and much to my horror, I discovered that they were interbreeding the birds with their close cousins who expressed the pied African grey gene due to the scarceness of the pied African grey out in the wild. It's interesting to note here that one of the reasons the pied African greys are so scarce in the wild is due to the fact of their being hunted for the few red feathers here and there besides the tail. Like right in here you see that he's got the pied kind of mutation going on there. People pay between $2,000 and $5,000 per one of these birds. In 2016, due to these and other horrific facts and mistreatment and mass deaths of African greys, the United Nations banned the global trade of wild-caught African greys. It would capture them and ship them via Africa Air. The main reason people would buy these birds is due to their intellect, not their appearance. Many people paying that much for damaged or injured birds during capture just to have one in their family. What these breeders may have done is actually breed out some of that precious and valuable intelligence that people treasured in this bird, and may have given the new clutch a bit of actual Down syndrome. In essence, creating a smart bird valued for its intelligence, abnormally stupid but pretty. So here we are back at a map of modern day Earth as per Google Earth, believe it or not. Now, one of the more interesting aspects of lorikeets, believe it or not, this beautiful little guy here, is that many times they actually have outbreaks of clap, which can be a mutated virus. It's very likely that the species was actually infected with it or a similar virus, and the actual virus had to figure out a way to preserve its host to ensure host survival, which may mean that the unique features of the lories and lorikeets possess, which is, a long brushed tongue for flower nectar, being brightly colored for easy identification, and a more successful reproduction rate may be a direct result of the virus changing the form of the birds for its own survival. Eventually, most of the species became immune to it, but by that time, it had helped to create the intensely sexually active, beautiful, intelligent birds we now call lories and lorikeets. If you're saying, oh no, these birds have this thing going on and whatnot, they evolved along with us. So, get it out of your head. We're going to take a little trip back in time to the Permian-Triassic period, roughly 251 to 289 million years ago. And I am going to do my best to show you my theory based on my research of part of the original form of Pangaea, Gondwana, and how these land masses moved. If I'm correct, the planet itself may be a little older than previously stated by scientists. So, here we go. Let's go ahead and go back in time when Australia housed Dicynodonts, Chigotsaurids stereospondyle, and a large quantity of Glossopteris plants. Now, as you all know, Australia is a moving landmass. It moves at an estimated 7 centimeters a year. So I think you know what's about to happen, right? Okay. So now we're going to shift Australia right here. This is the new position for Australia. As you all know, Australia's eastern region is tropical, okay? There's even a chance that Australia, during its migration, rammed the bottom end of China here. You notice there's like a little notch here, into modern-day Vietnam before coasting into its current position. Now, as you can see here, equatorial Africa and eastern Australia's tropical regions fit nearly perfectly. Right here. Even as far as to have a delta result where the western portion of Australia meets up with South Africa. Actually, these two land masses right here at a slight angle backwards fit perfectly. The land physically connects like a puzzle piece. There's even a section here that's reminiscent of an ancient river, much like how the modern Red Sea is today, as well as how the Red Sea sits in relation to its surrounding landmass and the similarities of the types of landmasses between Australia and Africa in this position. You notice here just a simple delta example is, this is a great tippy delta between Spain and Africa. And this is kind of what's going on here. It's a thicker delta. And the similarities between types of land masses and between Australia and Africa in this position. Another interesting fact to take note of is this notch at the top of eastern area of South America as well as corresponding area in Northwest Africa. Now let me go ahead and show you South America here. You notice these two land masses correspond. I couldn't get them to fit. My conclusion is that these two land masses rolled around on each other, kind of eroded the beaches on each one just during landmass migration. There's a gap here that indicates where Florida may have resided, but there's a complication in this reconstruction that I will elaborate on later on in this presentation. So we're going to go ahead and start off with Alfred Wegener's Pangaea map. This is from his Origin of Continents and Oceans. If you look here, he's got Australia sitting on the far end of Antarctica. And he's got South America kind of attached to Africa. He had to add a little bit of extra landmass here in order to create the fit. And let me go ahead and show you. Here we go, following in Alfred Wegener's footsteps here. I'm going to show you the Glossopteris in relation to modern day, the modern day planet here, with theorization, of course, to the Permian period Pangaea. So this is my Glossopteris fossil that I ended up finding online here. Isn't that cute? Right. Here's the South American Glossopteris colonies. Here's the African Glossopteris colonies. The Australian and the Australian Glossopteris colonies. Now, I'm going to end up proving to you that this area here also contains the Glossopteris fossils. So let's go ahead. This is my supporting evidence for the Glossopteris. This is Australia where the land began, biography of the Australian continent. The climate warmed after the ice age of the late Carboniferous and earliest Permian period, and a rich flora evolved that was characterized by the Glossopteris. Coal deposits were formed in extensive areas of cool temperature swamps where plant communities thrive. So it is already, this is the conclusion, the assumption that there is a relationship between the Glossopteris and coal deposits in Australia. Moving along. This is just an excerpt from Fossil Collector. This is actually an Australian publication that states that Permian floral assemblages from the Collie Basin, Irwin River, coal measures, Perth Basin, Carnarvon Basin, and Canning Basin of Western Australia's. We ended up doing a pretty large dissertation in regards to the discovery of these Glossopteris in these regions here in Australia. We have Glossopteris found in the Bowen and Sydney basins of Australia. For South Africa, of course, you have this is most Glossopteris are found in South Africa, which is interesting to note. And this is what we have going on here is a very big delta here. Is pretty nice connection. And if this water, there might have been a swamp back in the day, which meant that this was transporting a lot of Glossopteris seeds and whatnot all over both continents. And Africa is currently known as being one of the storm areas. So transport of these plants might have been even more efficient in regards to the storms. It might have assisted in the survival and the thriving of the actual plant. And this is evidence of reproductive organs of Glossopteris from Queensland, Australia. One of the things I want to go ahead and touch up on this is these coal deposits. We have already ascertained that the Glossopteris is partially to almost completely responsible for coal deposits in Australia. Now, if you look here, you have a coal deposit in Cully Basin, as well as in the Gippsland Basin and the Otway Basin near Murray, which puts the Glossopteris during the Permian period right in these two regions, connecting these two land masses right here. There are no mines in this area at all. Zero, like barely anything, even if it is Somali and whatnot. What you have going on near the area where I have parked Australia, you have plenty of diamond mines and coal mines, as well as all this rich mineral region that's being mined. So that brings this bad boy together. You even have like a reminiscent land bridge going on here from between South America and Australia, which would allude to the possibility of the Glossopteris just migrating from Australia into South America, or the other way around. We really don't know. And let me go ahead and introduce you to a little dinosaur that helped me in this compilation here. This is the Dicynodont theraspid from the Permian Triassic era. Let me go ahead and real quick give you an outline of these periods just to kind of refresh you. The Carboniferous period is from 299 to 359.2 million years ago. The Permian period is 251.9 to 298.9 million years ago. The Triassic period is 199 to 251 million years ago. My discovery, and I'll go ahead and provide arithmetic and calculations and anything that you need for proof, adds an additional 154 million years to the age of the planet thus far. So this is my Glossopteris. I'm sorry, this is a my Dicynodont. Yes, my Stereospondyle. You get to meet that guy later on. This is my Dicynodont. Isn't he cute? He kind of looks like a crocodile. He's got the little tusks going on there. This is West Australia's Dicynodont, South Australia's Dicynodont discoveries, as well as Brazilian Dicynodont discoveries. Let me go ahead and give you my supporting evidence for that. Digalodon rubidegi and Emidopoi Dicynodont from the late Permian of South Africa. This is from the Berlin Museum. And Dicynodont theraspids from lowermost Beaufort group, Upper Permian, South Africa. New Dicynodont theraspida Anmodinta from the Permian of southern Brazil, an implication for Bidentelian origins. Alright, the Australian Museum actually has these as well. Actually didn't indicate the period from which they come from, but here's from the Australian Museum, Dicynodont theraspid from Queensland, oddly enough. And some of them are in other areas as well. So that puts that Dicynodont in Australia, generally speaking, and it is a moving animal. So you have the migration of this group here through these three continents, and interestingly enough, to date, the only Dicynodonts that have been found on the African continent are literally in South Africa, which leads to the suggestion that this might have been swamped, would have been a great place for them to hide, and they are reminiscent of crocodiles. So there is a chance that this whole area, that marshlands from Australia were back in the Permian period, were still marshland. So we're migrating. Oh, there's another little cute guy, which is Chicotaurid stereospondyle Carboniferous Permian Triassic, from the Permian Triassic period, excuse me. There is a whole bunch of publications, just a quick note from about the Dicynodonts, that states the Dicynodonts are all over Africa, but I could only find Dicynodont samples from South Africa, which was kind of confusing. They were trying to get people to visit there or something. Anyway, these are Stereospondyle, yet another relative of the alligator and the crocodile. Isn't he cute? So we have these guys in Argentina, Brazil, in Western Australia, as well as South Africa. These are stereospondyle chigosaurids. Here is an excerpt stating that this amphibian from the Upper Triassic of Argentina and the phylogenetic relationships. This is the discovery of these particular animals in Argentina. This is stereospondyle amphibians from the Elliott Formation of South Africa. Wired space, I know, but it's still a paleontology publication. Here is one that states that the Commissarops Brachiopoidea chigotsauridae, late Triassic in southern Brazil. Yeah, Chigosauridae. Not so much. But chigosaurids are commonly found. A longest-lived Trematosaurid clade from Triassic to early Cretaceous reported in Argentina, Australia, India, and South Africa. Contribution reports a putative chigosaurid specimen in the Carnian off southern Brazil. Material comprises two skull fragments, a mandibular fragment, a clavicle blade, and a humerus. Ontogenetic features point to an early development stage of the specimen. So, yeah, in Australia, India, and South Africa. These are the stereospondyle migrations. Once again, they appear to have utilized a land bridge between Australia and South America. It might have even been just a shallow river, for all we know. So, with this information and these findings, I wonder if Wegener was trying to say with the mesosaur, oh, mesosaur, I got my butt kicked by a crocodile. Interesting, right? Considering how much the mesosaur looks like a crocodile. Now, if you look here, what you're looking at here is an elevation map. This is developed by floodmap.net of the world, pretty much. It's not the best one I've seen, but yeah, it's the only one I can find that actually has the whole globe. Now, if you take a look at this, you have similar landmass heights coming in from Australia, specifically in the eastern in the eastern regions here. Western Australia, not so much, but you also have something interesting going on here in the northeast portion of South America. Now, what I ended up doing here is I connected. Now you can see here this connection way better than I had mentioned before. Yeah, sorry about that. There's actually like this notch here. Which one is it? This notch corresponds with like this landmass here. It's has a higher visibility in this map. You can see this notch, and you can see this connection here going on. And you can see here the elevations are nearly the same between Africa and South America. So if we go ahead and we bring in Australia, you'll find it doesn't look anything like it, except for the elevations are almost completely different, except for this northern region. Now, I ended up finding out that a good portion of Australia are wetlands, believe it or not. So let me go ahead and bring that up for you. What you're looking at here are Australia's westland on the western portion of Australia. And you can see here Brixton wetland, Alcoa, Big Swamp, Weinman's Westland, and Dun Swamp. This is all swamp. Now, if you look over here, this is South Africa's wetlands. These are corresponding with the connecting point here between Australia and South Africa. It also alludes to the potential that there was a massive flood in this whole area. I mean, it already identifies the river. You can tell the shape of the river here. Give me 1 second. There you go. Shape of the river here, which further supports this connection here because you have the water going on. This whole area here is considered like wetlands and swamp and whatnot. So this was all flooded. So you would have had stuff like the Dicynodonts as well as the stereospondyle hanging out in the area, which would have also explained the massive amounts of crocodiles on Australia. They evolved from these creatures. There's more, by the way. This is a satellite view of modern-day Earth as provided by Google Earth, with of course my overlay here of these continents. I will use it to further and without a doubt prove my theory that Australia was most certainly once on the eastern coast of Africa and not on the other side of Antarctica, underneath China during the Permian period as presented by Alfred Wegener. One of the things you're going to find is that many parts of these connecting land masses edges are really well preserved. There's even an indentation of Africa if you look over here. You can see there's like an indentation on the it's the continental shelf, and it's shaped like Africa. On a continental shelf of eastern North America, which I found fascinating. I'm first going to show you what I believe the Western African Pangaea looked like up to what my research has indicated could be the mid-Jurassic to late Jurassic period, a subject I will go into further later on. But first, same principle. Here's Australia in the Permian Pangaea position. If you notice here, I couldn't really figure out where to put Tasmania on it, so I put Tasmania right inside Africa. There's like a little notch coming out of Africa, which shows off this section here. Yes, that is my brother that you're hearing. Yes, the man has psychiatric issues. But first, Australia and the Permian Pangaea region with Tasmania, and South America and North America. If you look here, let me go ahead and give you United States. If you're wondering why in the world I have just put half of the United States on this map, give me a minute and I'll explain to you further. There's even there's a slight notch here in the northern hemisphere that corresponds directly to the southernmost tip of Ireland. If you look here, I'm going to go ahead and give you Cuba on here. Alright, Cuba. Notice how the curve of Cuba hugs the South America. Cool, right? There's even a spot in here for Puerto Rico. Go ahead and drop Puerto Rico in between these two land masses. So let's go back to Australia. Now you're wondering, what the hell am I doing now? I've got Uluru highlighted here. There's no real particular reason why. One of the reasons I selected the satellite view of Earth for this portion is due to the clear visibility of the ocean floor. I decided to study the ocean floor and found odd craters around the seafloor around Africa. Are you ready for this? Alright. Alright, if you look here, can you see it? Alright. Let me go ahead and pull that back up. Remember what I was mentioning to you before about the two land masses merging perfectly? Well, here they are doing exactly that. See how the distances are nearly digitally perfect. Let me go ahead and get you a close-up of that. You see that? It is exactly the same landmass. They fit as like a perfect puzzle, even the curve at the base of Australia. So one more time, let's go ahead and show you. This is what I have highlighted here once again is Uluru. So let me go ahead and drop that out. There's your crater. And there it is. It almost appears to be a crater that collaborates with the position of Uluru on the map. But how is that possible? Well, let me go ahead and show you. What you're looking at here is a map from Columbia.edu of the subduction zones of the Earth. This shows the continental plates, lithosphere and asthenosphere, as well as this area here, which is called the subduction zone, where ocean water embedded in rock evaporates as the ocean floor continues to replenish itself, much like the activity in the lava lakes that exist on the surface of the planet. And by the way, I believe those are formed by volcanic explosions. Now, what I think is going on with these craters is that where the ocean floor meets here with the continental lithosphere, there could be water seepage right at the plane going on in here, kind of an aqueous layer, something I'm calling the aqueous layer. Wegener actually described a fluid-filled viscous layer of crust, which I now have reason to believe is correct. It's just supersaturated. It may be in essence a layer of mud due to the seepage that may be at the same level as the ocean floor, right near the beginning of the subduction regions of the continental plates. Think of it this way. Imagine a piece of paper between two bricks. If you drop water, kind of like have an offset or two paper hanging off of either side of the brick. If you drop water on one side and long enough, the water will seep through the paper to the other side, using the paper itself as a conduit. This discovery suggests that when the volcano erupts through you have the lithosphere and the asthenosphere. When it erupts through the asthenosphere and then through the lithosphere, punching right through the continent, it generates a mock anchor. Similar to what happens when a person hammers a piece of sheet metal onto a piece of wood with a nail and gently removes the nail. The warped metal, because when you nail a piece of metal in, it kind of comes up a little bit, physically anchors into the wood without the nail. The upper part of the continent keeps moving, while the lower punctured section, well, not so much. These seafloor craters, or what I'm like to call ghost volcanoes, while using the distances between land-based continental volcanoes, are literally the only reference points we have as to where these continents have resided prior to their current resting position in modern day. And they are extremely difficult to find. I was lucky to find a Permian Uluru on this map. Many scientists have been investigating the formative principles for how large mountain ranges are arranged. With this application of this aqueous layer theory, consider this for a moment. Proportionally, the movement of something like a mountain is an astronomical task requiring a lot of equipment and manpower, if the task is even feasible. But take this into consideration when it comes to landmass shapes. To adjoining landmasses, the weights are nearly the same. They are similar and can manage each other, kind of like back and forth. The weights of the landmasses is directly related to the thickness of the continental masses in relation to the upper crust. How can they bunch up that way? Well, we have tectonic plate movement and pressure upon each other, which is known to cause mountainous uplifts in the shape of the continents. Then there's migrating landmasses that impact. Imagine it this way: a small car has no chance against a semi-truck. If impacted by it, they can just take it out. Much like the result if a human tried to create a mountain on their own. But an impact between two semi-trucks and you get impact deformations. The metal rises up, high ridges in the outer shell of vehicles, deep troughs, and is similar when the two vehicles moving at relative speeds impact and interact with each other. Much like our planet's continents. Think of the continents as a bunch of semi-trucks with similar physical properties, just stuck in a traffic jam where there is no road and no stoplight available, where the destination is constant. If you look here at Vietnam, there's another weird looking formation on the ocean floor. If you look right here, oddly enough, looks like a crater. If you measure from the tip of what appears to be the northernmost point of Australia's impact to Thailand, and to this what I'm going to call now the ghost volcanoes, I've been calling them, and conduct the same measurement. This is right here. This is actually, give me 1 second please. This is 958.56 miles. Now if you look over here, this is the same measurement. It's not exactly the same, but you got land erosion, land migration. The volcano may have changed, but the distance is minimal. Is minimal difference. Actually, I ended up finding a measurement that was exactly the same between the tip and actual Uluru. It's cool, right? You're gonna like this. Alright, so here's a broader view of South Africa and the nice striations map. I call these striations. Some of it does appear to be simple, like a reformation of the ocean floor, but if you look at some of these spots here, it looks like something literally dragged itself across underneath of Africa. You have this kind of, these stretches going on here and coming up this way, and you have a secondary one. Hang on. This is a better map here, where you see kind of these large, strange-looking lines, and then you have even one spot here where it appears as if it kind of looks like the shape of Australia, where it might have resided there for an extended period of time prior to impacting into Thailand, Vietnam, and southern China, and then ending up in the resting space that it has here. It looks like something massive dragged across the ocean floor. Navigate towards the southern end of Vietnam, right up on Singapore. So let's have a look at this crater right below Vietnam. If you look here, there's another object right around this area that looks like a crater. Actually, it looks like there's several of them right below Vietnam. But like if you superimpose Uluru, if you take superimpose Uluru on the first crater and mark the second crater, you have, this is right here, 983.39 miles, right? So you have that going on here, the 983.39 miles, 3639, going up into New South Wales. And there's even, if you, it doesn't look like it now, but if you back away a little bit, you can kind of see it's reminiscent of an ancient volcano. Once again, these striations are clearly visible of the migration. You can see them here. Kind of like the results of the Australian landmass inching its way across the Earth's surface. But come on, there is no way Australia could move that fast, right, in such a short period of time. Well, the measurement here, hang on just 1 second. The total distance is the current distance between roughly for the whole journey, including slamming to Vietnam, not accounting for the pit stop, aka length of time it remained there. And time frame in transit is roughly 154,875,813.4 years. Current distance between South Africa and Western Australia is 5,337.34 miles. 1 mile equals 160,934 centimeters. Divide that by 7, since Australia migrates at a nice 7 centimeters a year, then by actual distance, and do the same with the distance between Australia and Vietnam. The impact alone more than likely caused both volcanoes to erupt, turning Australia into the beautiful landscape it is today. What scientists will eventually find is that the African greys are part of the Lori family due to all of this. That they are indeed loricates. I doubt the African grey. They are most certainly this gorgeous little bird right here. I doubt the African grey will develop the long brush tongue like the lorikeets due to the fact that this was an evolution and adaptation to the vast changing and harsh climate of the Australian migrating landmass. To survive with the help of an unlikely viral friend until conditions improved, including the abundance of food. In regards to actually defining the rest of Permian, Pangaea, and Gondwana, let me go ahead and show you something. I'm going to go ahead and explain to you why I've got, in the original Pangaea map, why the United States was lobbed off. Just one moment. In regards to accurately defining the rest of the Permian, Pangaea, Gondwana, besides these volcanic trails, and there are a veritable 10 of them all over the ocean floor, let me show you something. This is the United States, a rich fertile land on which we thrive relatively easy. If you have a look here, you'll notice two areas with a peculiar circular shape. Both of these are approximately 200 miles in diameter. Actually, the volcano here in question, you have one here, and then you have another one that's overlapping that's a little bit larger, and you can see the actual crater. Excuse me. The other one is one of them is a crater. Yeah, this is actually a freestanding magma core. And this one right here is a crater. These two volcanoes actually formed this section of the North American continent in an ancient colossal eruption. If you look at the first one side of the crater right here, this one at the top, is completely blown off. The lines you see trailing from these are literally from a magma lake that resulted from the explosion, which formed part of the mountainous regions of Mexico. I call these two the wife and the husband. Now, what you're looking at here as well is, it would have been a volcanically active region. This area here in red would be a crater, is reminiscent of a crater arc. There's even a few more others I couldn't find. They're just overlapping, just one on top of the other. And these orange-yellow regions are actually the large craters. They created the United States of America. This is a married couple. My theory is that with the metallic and chemical composition of magma, large stones form. The hardest one would be diamond. With no growth constraints whatsoever, these rocks can grow to be extremely large and lodge themselves within the magma chamber. Some still allowing for a curve within the magma chamber, causing pressure to increase, which caused the volcano in question to explode with tremendous force, with potentially multiple kiloton nuclear bomb strength. One of the interesting things as well on this is just a simple fact of an actual diamond forming. in the area underneath the crust. Then you have heat, and you have the formation of carbon dioxide, and you have the area should bubble up just by that. There should be specific set of circumstances for this to take place, depending on the size of the rock, of course. Kind of neat, right? One of the most valued treasures on the planet is one of the most dangerous aspects of it. Seems pretty hopeless. Well, here's some more proof that this actually takes place. Carbon dioxide. No, actually, that's something else. Unrelated information. If you heat a diamond, this is diamond carbon combustion. Can you light a diamond on fire? Yes, a diamond can be burned. The most common form of burning in everyday life is carbon combustion. In carbon combustion, carbon atoms break their bonds with each other and with other atoms, which requires energy to form bonds with oxygen atoms, which releases even more energy than first required. The net extra energy released in this reaction can then go on to rip more carbon atoms free of their non-oxygen neighbors. Thus, continuing the reaction, or the energy, can escape as heat and light. Carbon bonded with oxygen makes carbon dioxide and carbon monoxide, which are the waste products of combustion. So it's kind of a cascade reaction. And here's a little excerpt here. This is commonly known. Actually, Gia and De Beers both live off of this type of documentation. This is their bread and butter. Diamond formation in Earth's mantle. Geologists believe that the diamonds in all of the Earth's commercial diamond deposits were formed in the mantle and delivered to the surface by deep source volcanic eruptions. These eruptions produce kimberlite and lamproite pipes that are sought after by diamond prospectors. Diamonds weathered and eroded from these eruptive deposits are now contained in the sedimentary deposits of streams and coastlines. One of the bigger issues is that you have diamond corruption from the streams and coastline depending on the year. Depending on the year that the actual eruption took place. And volcanic carbon dioxide. Here you go. Every volcanic eruption that occurs on the planet Earth is full of pollutants, not just ash and dust, mind you, but also carbon dioxide, one of the strongest greenhouse gases on our planet. In the largest cases, a single volcanic plume lasting only hours might add many millions of tons of carbon dioxide to the atmosphere. So global warming isn't just about our cars. One of my theories about some continents moving faster than others directly involves the aqueous saturated layer that I discussed earlier. This seems irrelevant to this information, but bear with me. What if one of these stone-lodged magma chambers doesn't explode? It would stand to reason that weaknesses in the plugged-up regions of a potential supervolcano may allow for an eruption of a smaller magnitude, preserving the potentially deadly diamond cluster, or one large diamond. What if continental migration physically drags across the continental plates, in essence, leaving billions of stones in its path inside this theoretical water-saturated aqueous layer, turning into a few million, actually, mock roller skates for the moving continent in question? There's not enough heat to be destroyed, right? We may never know, but it would be like the diamond is in the chamber here. You have the shaft, right, and you have a ventilation shaft. Then you have the chamber, and the stone is in here. If it erupts, let's say like it bulges up and erupts outside here, and this continent keeps moving, it could literally erode away this rock. And the rock this is a really stable rock that we're talking about here. So it'll slowly drag itself across and slowly chip away at itself, slowly be chipped away by the actual movement of this cup that it's sitting inside. Just something interesting. It might be the reason why Australia is moving that fast. It's on a diamond roller skate. We may never know. However, there's hope yet. In China, the blasting of mountain sections has been achieved. Ready? It's possible to actually avoid this kind of volcano explosion by artificially weakening part of the mountain with an extremely precise set of explosions. We have the potential with this technology to even control where the magma goes, and if all goes well, to a safe location. This is man-made. I wasn't going to sit there and leave you crapping your pants, right? Interestingly enough, the University of Berkeley has used seismic waves bouncing around the inside of the Earth to take a CT scan of the interior of the volcano. University of California, Berkeley seismologists have produced for the first time a sharp three-dimensional scan of the Earth's interior that conclusively connects plumes of hot rock rising through the mantle with surface hotspots that generate volcanic island chains like Hawaii, Samoa, and Iceland. It's basically computed tomography or CT scan of Earth's interior from supercomputer simulation. Ended up, it said, while medical CTs employ X-rays to probe the body, scientists mapped mantle plumes by analyzing the paths of seismic waves bouncing around Earth's interior after 273 strong earthquakes that shook the globe over the past 20 years. Probably have a little diamond thing going on there, depending on the health of the planet. Actually, the healthier it is, the more likely it is to create one. But I don't think we'll have one of these cataclysmic extinction level type of diamond explosions for a long period of time. It would be clearly visible. I personally recommend caution with warmer than normal diamond mines with this kind of volcanic activity and ever forming land masses. Based on this, there is no true way to determine what the original land masses on the surface of the Earth looked like, and if they ever truly were all interconnected at all. Now here's something interesting for you from the PBDB Navigator from paleobiodb.org. If you look here, there's several fossils that have been found in South Africa. It seems to have that fossils were also found in corresponding locations on Australia. So let's move forward to the Triassic. Let's go ahead and let's do this from the Permian period. Let's go ahead and it's a really great little device. And these are all fossils from the Permian period you have in South Africa, as well as Western Australia and Eastern Australia, not much in Central Australia as much. So let's move forward to the Triassic period. And yeah, kind of taper off a little bit. And then let's go ahead and migrate towards the Jurassic period. Now, theory has it, based on what I've been telling you, and land formations on Australia, is that this was all swamp. So where the hell are all these fossils? There's like one going on here. Alright, if you look here at the late Jurassic, hardly any fossils have been found on either one of our continents of interest. As soon as it decides, there you go. But plenty of fossils exist from the Jurassic period, from the late Jurassic period, on other parts of the planet, heading into the Cretaceous period. Only ammonites and brachiopods are found, pretty much in these areas here, in the Cretaceous actually. It leads to a suggestion that right around the late Jurassic, something took place that not only abruptly ended the lives of the dinosaurs in this area, but it kind of decimated them. It literally decimated them. Life was doing pretty well. Oh, not so much in the early Jurassic it was pretty good. Yeah, early Jurassic was alright. Between early Jurassic and late Triassic, things were going pretty smoothly. And suddenly just everything went bye-bye. Which leads to the conclusion of some sort of a massive volcanic event in this region. Right before that. whatever it was, I believe that the events that led to less dinosaurs in the late Jurassic period in this region began Australia's pinball navigation across the surface of the planet. It might have been continuously erupting, not allowing the animals to survive. They had found like 300 million year old human bones up in this area. I wouldn't doubt it. If by chance there had been like a, because you look at this right here in the Jurassic area, I mean the amount of dinosaurs is phenomenal. We all know what the Jurassic era holds. Our favorite carnivores, the Tyrannosaurus Rex. So yeah, they probably would have done their best to migrate south, and probably would have had problems with this volcano. So human migration, just theoretical human migration, would have been from here through here, avoiding all this, and up into here and back and forth until right up in the Cretaceous period, where things get a little bit more comfortable, so to speak, in the Cenozoic. 315 million year old human bones found near this area of Africa. Can you imagine? And that would be it.